I'm making a quick video because over the past few weeks I've done quite a bit of designing for my laser cutter in SketchUp. That is to cut out designs in acrylic on my laser cutter. Obviously, as you can see, 3D designs. I've learned quite a few tips which have kind of fed into that. Just to give you a quick overview of my workflow, I usually start like this by laying out the faces in a 3D configuration, but these actually represent 5mm sheets of acrylic, even though they're 2D. I'm just doing that to make life easier for myself, so I don't have to change kind of extruded surfaces, because these are essentially 2D shapes that you're cutting on the laser cutter anyway. They are a sort of flat plane. So yeah, I'm designing it in a 3D configuration, but as 2D surfaces. And this particular design fits together using tabs and nut traps. If you imagine that this top sheet is 5mm thick, and this side sheet is also 5mm thick, this here is a tab which will fit into this hole. Here's a clip from my last video to show how those tabs look like when they're assembled. And you can see here each of these inside edges has a little circle designed into it. I had to draw all those circles manually, and they're 1mm diameter. That is 0.5mm radius, because that seems to be the finest measurement that that SketchUp can actually handle. It would have worked if they were smaller, but the reason for these is because the laser beam is essentially cuts a cylindrical hole out. So if I hadn't put that circle at the corner, these corners would obviously have, instead of being a right angle as it would appear in SketchUp, they would have turned out as a right angle but with a slight rounded edge, which actually wouldn't allow each of the flat surfaces to go fully into the join. So by putting this little cutout, you're actually making it possible to fit a 90-degree external angle into that 90-degree internal angle without any sort of clashing. So that's how to do a tab. Now nut traps are a little bit more complex to explain. Here's another extract from my last video of that exact part on the finished model, where I'm screwing the nuts into the nut which is caught in the nut trap. You can really only design them if you have the pieces laid out in 3D like I have here. So this area here, if you imagine that will be extruded in 5mm in this direction, this will take a nut. This would be an M4 nut in this case. There are really good tables on the internet which tell you the dimensions of nuts of various metric sizes, so you can work out the kind of maximum external dimensions that you'll need for that hole there. And this vertical slot here is for the bolt, and that corresponds with the circular hole here in the top plate. So if I show you from the top, this hole is aimed right for the center line of where that 5mm sheet of acrylic will be, heading straight down, and the bolt will occupy this vertical slot here and screw into a nut, and that nut will then pull this entire surface towards this piece here when you tighten the bolt. those were the two fundamental ways of actually creating a 3D shape from the 2D sheet of acrylic. The way that I convert this into a cut path for the laser cutter is using my own SketchUp plugin, which is available to download. There's links in various previous videos if you check out my channel. The way that plugin works is you just go to Tools, Create Cut Sheet as SketchUp file. That's your first step. Because this is 3D, it needs to be laid out in 2D. I've already done that, but I'll just... if I'd gone to that item in the menu, I would have created a new SketchUp file, which looks like this. So it's just taken all of those sheets and laid them down flat on the base of the Z-axis. And from that, assuming you're happy with the layout of the parts, I've just arranged them so they would fit easily within an A4 sheet of acrylic. Once those parts are laid out correctly, you go to Tools again and just say Export G-code from 2D drawing. Now this is all explained in a previous video, as I said. So that's my entire workflow, and then I just use Prontoface. You can use any sort of G-code sender to send that G-code path to your laser cutter. As always, I hope you found that useful. Please like and subscribe if you did. This is part of a larger series where I'm going to design and build a CNC router. Please do check out my G-code laser cutter and my G-code plugin for SketchUp. Thanks for watching and goodbye.